My name is Jeremy Vinker. I'm an operator up here in the Mono Basin. I've been working for Edison for about 8 years now. This is my supervisor, Brian Bays. So be good to him, please. It is very, as you can see, we got a lot of snow here. We're at about 7,200 feet in elevation here. We've received approximately 330 inches of snow this year, which is about, right now, about 120 to 140% of average. So a little bit better than normal year. We have a lot of ice on the ground, and obviously, you guys don't have crampons on, so please be careful when you're walking the ice. Take small steps. We don't want you to fall and go down. Because the nearest hospital is Mammoth Hospital, which from here is over 35 minutes away, okay?
And I've been there. I know how long it takes.
Oh no!
So we don't want you to slip and hurt yourself. In the event of an emergency, we're going to assemble right here. Emergency means earthquakes, accidents, fires, things like that nature. I'm CPR first aid certified. Brian, if you'll call 911, be able to direct emergency services here. Gotcha. Perfect. Does anybody have any questions or concerns about safety out here? Comments? All right, so in this powerhouse, there are a lot of things that can kill you very quickly, okay? We have exposed conductors, meaning there's no insulation on them, okay? You touch them, you die. We have rotating equipment. These things are over 10,000 horsepower apiece, okay? They are not going to even hiccup if you get caught up in them, all right? Do not touch anything without asking myself first or asking Brian. All the switches, buttons, levers, and controls are live. If you accidentally bump something, no big deal, just tell me about it, okay? If you hear the generator start screaming, whining, rumbling, groaning is a good word to describe a fault. Don't freak out, stay calm, all right? And listen to my directions. Brian, am I missing anything on that right now? Okay. When I take you in the control room, which is upstairs, you're going to see a board that has a bunch of silver plates on it with a bunch of switches, lights, and meters. I'm going to ask that you stay about a minimum a foot away from that guy, so there's no accidental bumping or anything, okay? Feel free to go anywhere else. All right, so here at Rush Creek, this powerhouse was put in commission in 1916. That makes this powerhouse over 100 years old. It was, I think we started construction in 1914. Don't hold me to it though. Currently, we're at full capacity here. We have 3 reservoirs up above here. We generate from one of those reservoirs called Gem Lake, G-E-M. We're moving about 102 CFS through the powerhouse right now, which is generating about 11.8, 12 megawatts. The reason we're at full capacity right now, can anyone tell me? Any guesses?
Snow?
Why are we using all the water right now at the end of the winter here?
Starting to melt.
Starting to melt, that's a good guess.
Water?
We have to drain down our reservoirs to empty to make room for everything that's about to melt.
Ah.
If my reservoir is already full and this stuff starts melting, what happens?
Flood.
Bad things, right? So surprisingly, we drain all our reservoirs. We also have legal requirements of reservoir level by a certain date. Usually that date is April 15th. Depends on what project you're on. Like I said, there's 3 reservoirs. The first reservoir up from here is at an altitude of around, 8,500 feet. It's Agnew Reservoir. We do not generate off of Agnew Reservoir. That is just a waterway, so we can get from the front of the lake to the back of the lake. It's a very small lake. It only has about maximum 810 acre-foot capacity. The next lake is the biggest lake, and that's what we generate off of, Gem Lake. It has an acre-foot capacity of about 17,000 acre-foot, almost 18,000. And we're generating off that right now. And then there's a reservoir up above that, which we call Rush Meadows. You will not find Rush Meadows on a map. It's actually called Wall Lake, but it was named after we licensed the project. So we're so old here in Hydro, up here in the Eastern Sierra, we have names for lakes that aren't on maps anymore because the lake's names have changed over time.
Wow.
What are the elevations of Gem and Rush?
Gem is 9,000 feet. I got a cheat sheet here. And Rush Meadows 95. Yeah, Rush Meadows 94. Excuse me, Gem 9, Agnew 85, roughly. So, I don't remember all the numbers usually.
And that's the height of the water right now, right, Jeremy? Not the
That is the
crest of the dam.
That's not the crest of the dam.
That's the elevation of where the water storage is at right now.
Okay.
Sure. So what kind of class is this? What's the name of this class?
Water resources.
Water Resource Management. So one thing that's really important to us here in what we call this Bishop Hydro, because our main office is out of Bishop, is we move water. Managing the water is almost our first responsibility. And then as a side cause, we also get to generate with it. We do not own the water rights to any of this water. Does anybody know who owns it?
State of California.
LADWP, that's right. They own most of all the water everywhere in California. So we get the privilege of generating with it as it passes through. One reason, this is a pretty unique powerhouse in that it is 2-story, but what's unique about it is that the generators are on the 2nd floor. When they were initially building this, they weren't sure what LADWP was going to do with the lake downstream here, Silver Lake. They didn't know if there was going to be another dam there to hold more water. So the reason they put the generators on the 2nd floor was because they anticipated the water coming up into the 1st floor. So that's one unique feature of this powerhouse. In 2017, we had a high water year, and we had a lot of water to move. Through a lot of our efforts, we were able to move 504 CFS down this water chain. 100 through here, and then the other 400 up above. So we have the ability to move a lot of water through this system here. Anybody have any questions yet? No?
How much?
Go ahead.
How much power can like 504 CSF generate?
We cannot generate with the 504 CFS. We can only generate with the 102 that I have coming through here. The other 400 is fuel down the creek.
Okay.
So, one cool thing about hydro generation, I don't know if any of you guys know this, it's one of the most fuel efficient forms of energy that we have. It's also the cleanest. I don't have any smoke, fumes, or byproducts coming out of this powerhouse except water. When the water hits the turbine, and I've got pictures here for you guys to throw around, when the water hits the turbine, there is up to a 98% transfer of the water's energy onto that turbine. That's what makes it one of the most efficient forms of energy. And I'm biased because I'm in hydro.
95?
90 up to 98.
How does that compare to wind?
Hold that for 1 second. We got a question of how does that compare to wind energy? I don't know. I don't do wind turbines. So what was your question?
Do you supply all of the energy to the area?
We are a mass exporter of energy. When we are at full load, yes, we supply most of the power, and we export a lot of power down south.
So the energy question, 1 megawatt equates to about 1,000 homes. So we have 11 megawatts coming out of this plant right here.
Yeah, we have in Bishop Hydro, we only serve about 20,000 customers, I think, is our meters.
Yeah.
So we usually are exporting energy. So think of a line from LA all the way up to here. A bunch of transmission lines, okay? We're at the end of the line. We don't have any interties to Nevada Energy or PG&E or anything. Okay, so we are the end of the line, one line. So if the power gets cut off midway, how do we keep power on? We use our powerhouses. Okay, so that's one really cool thing that we do here specifically in the Mono Basin. I have 3 powerhouses I use, this is one of them, and we run isolated quite a bit.
So what do you do with the energy that you don't export to the grid? How do you store it?
Okay, so good question. AC energy, can you store AC energy?
No.
Alternating current energy?
No.
No, you can't. You can store DC, right? Direct current, we have those in our car batteries. You can only generate what is currently being used on the grid. You can't store it. Okay? So, when we have, say, 25 megawatts of power that we're producing, and then my load is usually around 5 megawatts like today, I have to curtail all 20. So the voltage will go super high. It's called high potting the system, and everything will blow up, burn up, okay? So we curtail our generation, and the devices we use in our plants are able to do that almost instantly. So that was a great question.
So we do have some form of energy storage, and that is storage of water in the reservoir.
Gotcha.
That is essentially,
Right.
potential waiting to be
Yeah.
used.
Okay.
Right. So has anybody heard of, what do they call that? The battery storage.
And they're in our EGT sites?
Yes.
Yes.
So one of the forms of energy for the future that Edison is developing is putting in huge batteries so that we can store some of that. We change it into DC, okay? And then we store it. And then during times of peak loads, we can export it. So that's one thing that we're doing in Edison. In fact, we're going to hopefully be building one up here in Bridgeport in the near future. So I don't know if it's Tesla or GE yet. I haven't seen it.
Yeah, no specs have been released
Yeah,
yet.
I don't know. So I'm just going to go over my notes here real quick. Let me pass this around, some pictures, so you guys can start looking at it. You're going to see a picture of, this is an overall picture of our system here, all the way from the powerhouse all the way up. The white line is the penstock, okay? One thing that we got to do every year is we have to take care and maintain all of our assets up the hill, all the dams. So how do you get 1,400 feet up just to the first dam with 10,000 pounds of concrete? Any ideas? It's a challenge, right? So one way we used to do is use mules. We'd pack mules up there.
Is that why you guys have so many mules around here?
No.
No? Well,
Good question, though. There is a pack station right down the way, and we do employ them sometimes. So Edison likes to be a little spendy. We like to use helicopters.
oh, wow.
Okay. One thing we have that's unique to this site, though, is we have something called a tram. And it's the rails actually, the metal rails on this are actually from the old Bodie railway, excuse me. And so it is a cart that is fastened to a cable at the top. And this cable winds up and it just pulls everybody up. We can take 10,000 pounds of people and equipment at a time. It takes about 17 minutes to get up there. So we have a tram system to get men and materials up. We usually conduct all of our maintenance in the summer, right? So we're not going to dig through 20 feet of snow just to start maintaining stuff. We got to wait for the snow to melt off. Currently, we have roughly, the snow as of March 1st was 115 inches deep up there, and 125 respectively at each dam. So we got a lot of snow to melt off still. Brian, do you have anything more to add?
No, I don't. Very good. Thank you, Jeremy.
Okay.
What would it be compared to, like, the drought years and stuff like that?
So
Snowpack.
the best way the best numbers that I can give you to give you an idea is, is everyone familiar with Mammoth Mountain ski area? Mammoth Mountain? So the Mammoth Mountain main lodge is at 8,900 feet of altitude. We have a substation that's about 8,800 feet, 100 feet lower. So when we look at the weather coming in, I want to look at what the worst is, so I know I can prepare, right, for snow removal. So to date, that substation has received 430 inches of snow. A drought year will only see about 220. So that 220 inches, that doesn't sound like a drought, but it is. So we like to try to measure the snow in feet, not inches, though. It gets really deep up here. At that location to date, I've received, like I said, almost 35 feet of snow so far. So good question. So the dams up here, I do want to note they're arch design or multiple arch design, and you'll see them in some of these pictures going around, and they're extremely, extremely strong. And they all go all the way down to the foundations. I mentioned a turbine. This is what a turbine looks like. You won't see it today because there's a covering over it called a bonnet. This is one solid piece of stainless steel. It's old water wheel technology. I mean, they built this 100 years ago. Still works today. So this is one solid piece of stainless steel. It weighs over 10,000 pounds here. And this is what it looks like. This is what the water's hitting. It's called a Pelton wheel with those buckets. The water hits right in the middle, okay? So you guys can check that out.
Do you guys have to do any maintenance on that? Like, do any critters get stuck in it, or?
No, no critters get stuck in it, but yes, we do have to do maintenance on it. Over time, water still almost kind of like does a sandblasting effect, for lack of better terms. And so every year we do something called annual inspections where we shut the generators off and we go through them and we look at everything. We pull them apart. And one thing we look at is that Pelton wheel. We're looking at pitting, any cracks, which is really bad. Okay, usually we don't find those at all, just pitting. And our mechanics will go in and weld back extra material into those buckets. Okay, that's how we do some of our maintenance on them. It spins something called a rotor. This is what a rotor looks like, and that's what you will see going around today. Now rotor, all those black things on there, each one of those is a magnet. One's north, one's south, one's north, one's south. Okay, and that's how we make our electricity, electromagnetically. Okay, so that's what's spinning. And then it's spinning inside this, which is called a stator. Those are just a bunch of copper windings. So when the rotor spins inside the stator, okay, that's how we're making electricity. On a really simple level. Has anyone ever played with those little iron filings and magnets when you were kids? And you'd see the iron filings kind of go around from one end to the other. Okay, we call those electromagnetic lines of flux. When those electromagnetic lines of flux pass through a conductor or pass through a copper winding, a voltage is induced. It's that simple. I don't know why it does that, but that's what it does. So the rotor spinning is big magnets making a bunch of lines, and all those lines are passing through the copper windings. That's how we make electricity. You won't be able to see it, can't smell it. The noise you're hearing isn't the electricity, it's just the water. So, and I'll point it out to you on unit number 1. There's a small gap between where the rotor's spinning and the copper windings, and you can look right through it. And that's where all the magic's happening, but you can't see anything. So it's pretty cool. So you can take a look at that. Any questions at all yet? I'm going to start asking you questions.
Would you say that hydroelectric power is mostly more efficient than solar because you don't have to take the duck curve into account in terms of like exporting power to the grid?
Yes. But remember, I'm biased.
He works for
Okay. There's something called VAR control, volts, amps, reactive. Okay. We have to control VARs on a grid, on a system. Okay. This is just a byproduct of making electricity, is a VAR. Okay, I'm not going to get too in depth with it because you can get lost in the weeds real quick. But essentially you have to manage the VARs to have an effective electrical grid system. To date, I am not as familiar on solar systems, but they do not have as good as VAR control as spinning generators do. Okay? Now they are making, what are those things that they make on the solar panels?
The inverter.
The inverter.
The new inverter system is what can equate to some bar control on there.
Right.
But depends on this type of solar system. If it's a photovoltaic system, the type that's on your roof, those are typically about 50% efficiency for the sun rays you get in.
Yeah.
And if you have the parabolic mirror set up where they're actually reflecting the sun's rays up to a collector, and it's heating, I think the common fluid is fluidized sodium is what they're pumping through that, and then to a heat exchanger.
Yeah.
There's a great deal of energy loss in that process.
Exactly, and then you have to take into account peak and off-peak hours.
Yeah, if the sun's not shining,
yeah,
you're not getting any of that. Of course, winter also. With your typical like combustion turbine, it's being fired off of natural gas. Those are somewhere between 25 and 30% efficiency. Where here we have almost a 90+% conversion rate, because energy cannot be created or destroyed, right? You can only just transform it from one state to another. And in this process right here, it doesn't get much better.
Solar panels generally also lose about 10% of their generating power per year. So at a 10-year-old solar system is going to be operating 10% less efficiency. Excuse me, 1% a year. Yeah, 1% a year loss. So that they do lose a little efficiency. Or someone mentioned the duck curve, basically. The duck. Does anyone know what the duck curve is?
No.
So one thing that we're seeing happening in California with all the solar panels going up is you go from 6 a.m. all of a sudden the sun comes up, and all of a sudden we have a lot of power being produced. Okay, that's called the duck curve. Okay, and then at 6 p.m. the sun's going down, and we lose all that power generation. Okay, but we still have power demand, especially at 6 a.m. and 6 p.m. when people are at home, right? So somewhere we have to make up that energy. And that's one thing that California is really struggling with is we have huge generators out there that can make what, 2,200 megawatts, like nukes, especially out of Arizona. Those kind of generators are designed to operate at one level. They don't like to go up or down, okay? So how do we lower our generation on fossil fuels and other technologies when solar is starting to create a lot of energy? That's the duck curve. So you're going to see that as one of the challenges that the energy market has in the state of California. So that, plus you still need the VAR control. You need spinning reserve for the VAR control. So a lot of challenges there. Good question. Anyone have any other questions?
When were the dams built, and have you ever had to do like some emergency fixes on them? Or are they just...
The dams have not required any emergency fixes, no. The dams are very strong and sound.
Okay.
And they were constructed prior to 1916.
Okay.
So, question?
How many years does this event expect to last?
Woo! That's my second Michael Jackson move for the day. All right, so how long are they expected to last? Here in the hydro world, we do something called FERC licensing. The Federal Energy Regulatory Commission is the federal body which allows us to operate, okay? We have to get permits and licenses from them to operate this system. Typically, a FERC license is every 50 years. This station is up for relicensing 2027?
Yes, 2027.
2027. So it takes about 5 years to relicense a project. So in 2022, we're going to begin doing that. We have a separate department inside Edison called Dam Safety, DSOD, and they are responsible for always inspecting and maintaining those dams. Okay, every year we're inspected by FERC at those dams for the conditions. They'll go in and say, see that weed there? I don't like that weed there. Pull that weed. Or stuff like that, okay? So every year we'll do an inspection, and then we'll be compliant on remedying, is that a word?
Yeah.
Fixing any recommendations they give us, okay? So I are a college graduate. Yeah. So we do minor maintenance, upkeep, but concrete can last a very, very, very long time. It's lasted 100 years so far.
Check out the Colosseum in Rome.
Yeah.
Right? Thousands of years. Typically a generating hydro unit, if it's well taken care of, can run for about 50 years before it needs a major overhaul. The dams themselves, there's been minor hand patches, things like that done through the years, but it's the same dam that was, structure hasn't changed. There hasn't been big reinforcement since it was built, the early 1900s.
We do upgrades to the dams to make them last longer. We have something called geomembrane that we've put on the water side of the dam. It's like this really thick material. You can't even cut it with a knife. And we layer that on top of the dam to extend its life. So there are things we do as new technologies come out, we'll put new technologies on it. But we don't have it lasts for a long time. Hopefully it's longer than my career. I'd like to have a job. Yes, ma'am.
Jeremy.
Any animals affected by the dams? Good questions. I don't think any animals are affected by the dams other than the fish get more water to swim in.
You guys have issues with invasive species in the reservoir?
We do not have issues with invasive species, to my knowledge, on this system at all. Not like the quagga mussel or whatever that was. Yeah. No, not up here.
Luckily for us, recreation, if you want to recreate at these facilities up here, you're going to have to either take a mule or a horse or hike to get to it. And then, of course, motorized boats are not permitted. You'd have to have a permit to do that, or you take a kayak or a float tube or something like that.
Less,
So that alleviates the invasive species contact.
like less anthropogenic activities there.
Correct.
you'd say,
Yes, correct.
It's good old mountain trout.
Who has access to the tram? Just you guys?
Well, everyone has access to the tram. I mean, it goes up and it cuts through the actual public trail all the way up, kind of crisscrosses it.
Yeah.
But Edison is the only personnel who uses it.
Oh.
In the past, when the sheriff has a search and rescue operation here and has asked us to cooperate with them, we always give cooperation with them. So, good question.
Jeremy, can you speak about your background? You said I are a college graduate. Yeah. Did you have a little different experience in getting into this position?
Sure. I was in the military for a few years, then I got out, and then I went to Cal State Long Beach, and I have a degree in communication studies, which you can tell I didn't really take to it. like we said earlier, it's one of those things. He's like, yeah, I'll never use that again. So hopefully that's a brief overview of what you're looking for.
Yeah,
And
the
then-
idea that you can do so much with your degree, even if that's not the path that you chose necessarily.
Right. I had a person I thought highly of always tell me the job chooses you, you don't choose the job. So this job kind of fell in my lap. I grew up here in June Lake. I went to school in Lee Vining. I spent 10 years away doing military in school. And then at that time, my wife and I wanted to be back up here. I was in property management in Mammoth for 5 years. And then an opportunity with Edison opened up and I took it. So I suck at math. I suck at science.
I was gonna say.
I hated it in high school. I avoided it, like I barely passed statistics in college. I mean, I barely passed statistics. But it's interesting, I use a lot of it here in this job. So sometimes you never use what you go to school for. But college is great because what does it teach you? It teaches you how to manage your time, right? Syllabus, like what the heck does the prof want? Give it to her, right?
So as far as like running operations on here, visuals and maps, do you guys make your own maps? Do you guys do your own like data visualization and all that?
For maps, we don't have like a GIS department making really high-end maps that are super accurate up here. One thing we do have is electrical one lines. We have a lot of prints and drawings for everything around here, okay? We don't have like a map of it's like a generic map of the station, but we're more concerned about everything inside. So, good question though. Are you looking for something more specific?
No, that was
Okay. Okay.
Well, and I wanted to mention, Michael over there in Matt, we have a pretty amazing drone program going on right now. I'm saying our drone program.
Oh yeah. Do you guys use drones at all for anything up there yet, or?
SE does use drones. In fact, our helicopter pilots also have drones. They're using them more and more. So when we get back here, when I take you back here, I'm going to show you the penstocks, which is what the water comes down in, the big pipe water comes in. We used to have a guy named Larry Ford, who was our penstock inspector. And he was small. He retired a few years ago. But that dude used to we would open up a manhole, drain all the water out, and that dude used to like get a rope, tie it around him, and go down the penstock, looking at it, like super scary. So we've talked about using drones to do that now. So, but those are only required every 5 years, 10 years?
That internal inspection?
Yeah.
Yeah,
I don't know, we do it when they tell me to do it.
How about drones for like checking the reservoirs and stuff? You just send them up there rather than going up there only
the
in the
company's
summer.
working right now to get the proper FCC licensing in order to do that.
Oh.
There's a lot of things in that you guys are probably as well versed in with the drones and licensing, using them for commercial applications.
Yeah.
There's tons of restraints right now, and I don't think anybody has all the answers.
Yeah, even the FAA doesn't have
Yeah, no one doesn't. Just don't use near the airport, basically, and you're okay.
Are you guys doing those drone programs in-house, or?
Yeah. Eventually there'll be trained drone operators up here, and the drone will, they fit in a suitcase.
Yeah,
Nice case. They could be ponied to you to your location. Our internal mail service, delivered to you. You do the work. You pack it up and send it back. That's the interim or the long-term goal with SE's drone program. And then of course there'll be dedicated drone operators in the system, if they go around, that's primarily all they focus on is tower inspections, circuit inspections, reservoirs, things of that nature.
Can you guys briefly talk about what you do day to day?
Make him happy.
Man, it's in a lot of meetings.
Is it like, are you all wearing a lot of different hats? Or is
Yes.
Okay.
So we're pretty unique up here in the Bishop Mono Basin. My office is in Lee Vining, which is about 11 miles north of here. And SE is a big company, but we don't have a lot of manning and resources up here like we do down south. So we wear lots of hats up here. So on a day-to-day basis, you can see my truck here. I'll do the shoveling of snow removal. I'm responsible for running these plants. I'm responsible for being able to isolate these plants and run them isolated. We have substation operators. You guys ever see those yards with a bunch of electrical equipment in them, like that?
Yeah.
That thing over there, that's called a substation. We have a whole separate department for substation operators down south, but up here we don't. There's 3 of us, including myself. So we're also trained substation operators. So we do plant operations and substation operations. From time to time, I'll be called by troublemen saying, go patrol that line, look for a line down. I clean toilets. So I'm a janitor. So yeah, we wear lots of hats. I do job walks, I do tours, engineering job walks, area familiarization, and occasionally I have to hike up this stupid thing. So yeah, we wear lots of hats. Yeah, it's kind of cool. You get to see all the worlds. Yes, ma'am. Saturday, Sunday.
Everybody.
Oh man.
Today.
When there are really complex operations, yeah, today's a good one. I like today. It's fine. When we do complex operations, when we're running isolated, I'm shifting loads between plants. That's really cool. I nerd out on that. So, any other questions? All right, let's divvy up into 3 groups. You know, like here and here. If I did 2 lines, and I'll take this first group. Okay, we're gonna go. Everyone listen to me real quick. I'm going to just give this safety briefing once. We're going to go in this door, and there's going to be some spiral stairs. You're going to go up those, follow me up those spiral stairways, and you're going to come it's going to end right up on the floor. And there's going to be a generator right in front of you. Please don't freak out. Okay? Immediately look to your right. You'll see the control room and everyone going in there. Go ahead and just walk into the control room, and then I'll explain to you what you're looking at. After I explain to that, I'll let you go out and just take a look at some stuff, okay? Everyone good?
Yeah.